This is SpaceTime, Series 25, Episode 65, for broadcast on the 15th of June 2022. Coming up on SpaceTime, a new study says Earth's magnetic poles aren't about to flip after all, discovery that the planet Mercury has magnetic storms, and we look at the latest missions to Earth's moon. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
A new study claims the South Atlantic Anomaly, a mysterious region where the Earth's geomagnetic field strength is decreasing rapidly, does not mean that the planet's poles are about to flip polarity. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, pieces together evidence stretching back more than 9,000 years and suggest that the current changes aren't unique and that a pole reversal may not be on the cards after all. The Earth's magnetic field acts as a shield, protecting life on the planet from the relentless stream of charged particles from the sun's solar wind and the constant bombardment of cosmic rays. Were it not for Earth's magnetic field, the solar wind would erode the planet's atmosphere, degassing Earth's water into space and irradiating the planet's surface. In fact, this has already happened to Mars, when its core solidified and its magnetic field stopped. Most of Earth's magnetic field is generated by the planet's molten liquid metallic outer core, swirling around a solid iron inner core, which generates electrical currents and a geomagnetic field. When solar storms from the sun overwhelm the Earth's magnetic field, they can disrupt communications and navigation systems, black out power grids, damage or destroy spacecraft, shorten satellite lifespans by causing the atmosphere to expand and contract, thereby increasing atmospheric drag on spacecraft, causing them to use up more fuel, and pose radiation health issues for astronauts in orbit and even people in high-altitude aircraft. However, the Earth's magnetic field isn't stable. The magnetic north and south poles tend to swap places. Compounding the problem, over the past 180 years, Earth's magnetic field strength decreased by about 10%. Simultaneously, an area with an unusually weak magnetic field has grown in the South Atlantic Ocean off the coast of South America. This is an area where orbiting satellites malfunction as the shield provided by the magnetic field is weaker in this region, allowing charged particles from the Van Allen radiation belts, as well as from the sun and cosmic rays, to penetrate deeper. Problems become so bad, NASA is forced to shut down the Hubble Space Telescope whenever it orbits over the area. And laptops used by astronauts aboard the International Space Station have been known to suddenly crash above the anomaly. Earth's magnetic field is often visualized as being a sort of powerful dipolar bar magnet stretching across the center of the planet and tilted at about 11 degrees to the axis of rotation. However, the growth of the South Atlantic Anomaly indicates that processes involved in generating this field are far more complex. These developments have led to speculation that Earth may be heading for a polarity reversal. Similar polarity reversals occur on the Sun every 11 years or so, and they've occurred on Earth on multiple occasions through the planet's history, at roughly 250,000-year intervals. The problem is, the last polarity flip on Earth occurred some 770,000 years ago, so we're well and truly overdue for the next. However, the new study suggests that this may not be the case after all. The study's lead author, Andreas Nielsen from Lund University, says careful tracks of changes in Earth's magnetic field over the last 9,000 years suggest anomalies like the one in the South Atlantic are probably just a reoccurring phenomena linked to corresponding variations in the strength of Earth's magnetic field. Nielsen's results are based on a careful analysis of burnt archaeological artifacts. These include clay pots that have been heated to more than 580 degrees Celsius, volcanic lava that solidified, and sediments that have been deposited in lakes or in the sea. The objects act as time capsules and carry information about the magnetic field in the past. Using highly sensitive instruments, the authors have been able to measure these magnetizations and recreate the direction and strength of the magnetic field at specific places and times. Nielsen says his team have developed a new modelling technique that connects these indirect observations from different time periods and locations into one global reconstruction of the magnetic field over the past 9,000 years. By studying how the magnetic field has changed, researchers can learn more about the underlying processes in the Earth's core that generate the field. The new model could also be used to date both archaeological and geological records by comparing measured and modelled variations in the magnetic field. Nielsen claims that based on similarities with the recreated anomalies, he predicts that the South Atlantic Anomaly will probably disappear within the next 300 years, and the Earth isn't heading for a polarity reversal, at least not yet. This is SpaceTime. Still to come, discovery that Mercury has magnetic storms and a flotilla of missions heading to the moon. All that and more still to come on SpaceTime. A new study has confirmed that the planet Mercury, the nearest rock to the Sun and the solar system's smallest planet, has geomagnetic storms similar to those we find on Earth. The findings, reported in the journal Nature Communications, answers the question of whether other planets, including those outside our solar system, could have geomagnetic storms regardless of the size of their magnetospheres or whether they even have an Earth-like ionosphere. The study also proves that Mercury has what's called a ring current, a donut-shaped field of charged particles flowing laterally around the planet, excluding the poles. This ring current triggers the tiny planet's geomagnetic storms. A geomagnetic storm is a major disturbance in the planet's magnetosphere, caused by the transfer of energy from the solar wind. Such storms in Earth's geomagnetic sphere produce aurorae and can disrupt radio communications. The study's authors claim the processes generating Mercury's geomagnetic storms are very similar to those affecting Earth. But the main difference is the size of the planet and the fact that Mercury has a very weak magnetic field and virtually no atmosphere. Confirmation about geomagnetic storms on Mercury came thanks to a fortuitous coincidence. A series of coronal mass ejections from the Sun way back on April the 8th through to the 18th, 2015, and the end of NASA's Mercury space probe, which was launched in 2004 and crashed onto Mercury's surface on April 30th, 2015, at a programmed end-of-life mission. A coronal mass ejection, or CME, is an ejected cloud of the Sun's plasma, a gas made up of charged particles, and this cloud includes the plasma's embedded magnetic field. The coronal mass ejection on April 14, 2015, compressed Mercury's ring current on the Sun-facing side and increased the current's energy. A new analysis of data from MESSENGER as it dropped closer to the planet showed the presence of a ring current intensification, which would have triggered a geomagnetic storm. But that doesn't mean that Mercury has geomagnetic storms similar to those found on Earth. On Earth, geomagnetic storms produce spectacular auroral displays, which occur when solar wind particles interact with molecules in the atmosphere. Now, on Mercury, however, solar wind particles don't encounter an atmosphere. Instead, they reach the surface unimpeded and may therefore be visible through X-ray and gamma-ray examination. The MESSENGER results provide a further fascinating insight into Mercury's place in the evolution of the solar system. This is SpaceTime. Still to come, a whole bunch of missions about to launch to the moon. And later in the science report, yet another reason to start the day by drinking a cup of coffee. All that and more still to come on SpaceTime. When the crew of Apollo 17 blasted off from the surface of the moon back in 1972, no one thought it would be more than half a century before people returned. But as political priorities changed on Earth, the moon was forgotten and a generation of scientific endeavour was mothballed. Yet the historic images of those Apollo moon landings and names like Armstrong, Aldrin and Collins were seared into humanity's collective memory. After all you had to do was look up for a reminder. NASA's Artemis project to return humans to the moon and eventually fly them onto Mars has now sparked a massive resurgence in scientific endeavour. Governments around the world, together with dozens of very different commercial and scientific organisations, have joined forces to develop a whole range of missions to the moon to better understand Earth's nearest celestial neighbour and prepare the way for our return. Now, these range from the massive Lunar Gateway space station project, which will act as an orbiting staging post for missions down to the lunar surface, right through to tiny specialized CubeSats undertaking specific scientific readings from lunar orbit. Larger studies will survey the lunar surface in great detail, while still others will provide communications and navigation services both across the moon and between the moon and the Earth. While SpaceX have already been awarded a contract for a lunar transfer vehicle, which will transport people and equipment between Gateway and the moon's surface, NASA recently announced plans to award a second lunar transfer contract with another company. It follows the same line of thinking which has seen multiple companies providing commercial crew and commercial supply transport services between the Earth and the International Space Station. It's a case of not putting all your eggs in the one basket. Other missions will deliver supplies, habitat modules and rovers to the site of a planned future lunar base near the moon's south pole. The plan is to have enough equipment on the ground to allow astronauts to spend several weeks at a time on the lunar surface and even explore further afield than was possible during the Apollo era. But like the communist Cold War against the West, which loomed like a foreboding shadow over Apollo, not everything now is going smoothly. The horrific images of Russian attacks on civilians in Ukraine and the ongoing reports of war crimes by Moscow have shocked the world. That's put a sudden stop to several joint Russian-European and Russian-American lunar projects, including Moscow's involvement in Gateway. And Beijing's illegal stance on the South China Sea, its aggressive actions towards neighbouring countries, to nations undertaking freedom of navigation flights through the area under international law, and Beijing's many human rights abuses against its own people are leading the communist dictatorship into its own isolationist world. Little wonder that Moscow and Beijing have signed their own Axis agreements, which will now see them develop their own separate lunar space station. But like Apollo, the divisions caused by Moscow and Beijing are simply bringing the nations of the free world closer together. And so work on Artemis continues, with the moon well and truly in sight. This report from ESA TV.
The European Space Agency is working to take humans beyond low Earth orbit and deeper into the cosmos. Our next destination on this journey is the moon. The 1960s and 70s were an incredible era for space exploration. The Ranger missions from the United States took close-up images of the moon before eventually impacting the surface. NASA's Surveyor missions demonstrated a controlled soft landing at the surface of the moon and tested the properties of lunar soil to prepare for future human missions. A series of Soviet landers and rovers visited a number of locations, performing scientific investigations, driving across the surface and returning samples to Earth. But the pinnacle of this period of exploration was Apollo and the arrival of humans at the surface of another solar system body for the first and only time in history. Looking back now, though, we see that only a tiny fraction of the moon's surface has been explored, all on the side of the moon that faces the Earth and in a region close to the equator. We've also discovered that all of the samples we have returned to Earth are from an unusual region with a complex and exotic chemistry of potassium, phosphor, and rare earth elements such as thorium. The vast majority of the moon has yet to be explored, including the entire far side. One thing that we can say for certain is that if we want to understand the moon, then we need to go back there. Now, after decades of waiting, an armada of missions from around the world, including ESA's Smart 1, have returned to explore the moon from orbit Looking down from above, these missions are providing a wealth of new data, bringing a new understanding and raising new questions. The next destination will be unlike anywhere we have been before, the extreme and alien landscape of the lunar South Pole. Here, we find areas of permanent darkness and extreme cold where water, ice and other chemicals can become trapped. And as we come up from these lowlands, we see towering peaks basking in near constant light. On these polar mountains, the sun rarely sets below the horizon, providing the potential for near continuous solar power and a spectacular view over the rugged and cratered landscape below. In 2009, the L-Cross mission blasted water and other chemicals out of a permanently dark crater in the South Polar region, allowing it to be observed by nearby spacecraft for the very first time. We also now know that there are nearby locations with similar cold conditions. Is there water here too? If so, how much is there? Where did it come from? And what can it teach us about the origins of water and life-forming chemistry on Earth? This water may have been delivered by comets and asteroids impacting into the surface over billions of years. It may even have been created at the surface of the moon. We now know that protons thrown out by the sun in the solar wind arrive at the lunar surface. Here, they react with oxygen in minerals to create a thin layer of water. These water molecules can be lifted by the sun's heat before falling again to the surface. Over time, these particles may move to the polar regions, where they are trapped by the cold conditions. And as we stand at the pole with the Earth in view, we can point our antennas to the sky to search for faint signals from deep out in space. But radio noise from the Earth is too loud and blocks out many cosmic radio sources. But as we move over the horizon, the Earth sets out of view. The noise disappears and a new kind of radio sky emerges. We see our galaxy and the planets as never before, and beyond, a quiet radio hum, a signal from the cosmic dark ages more than 13 billion years ago, when the first cosmic structures were formed. And now, the moon as we see it today, scarred by craters formed by billions of years of impacts, and the largest and the oldest of these, the South Pole Aitken Basin. Formed by a powerful impact around 4 billion years ago, many believe that its formation marks the start of a dramatic period of bombardment onto the Earth and the Moon, an era called the Cataclysm. This era is recorded on the Moon's scarred surface, and its end coincides with the appearance of the earliest observed traces of life on Earth. In the coming years, we will see explorers at the lunar poles, exploiting the extended sunlight for power and performing research to benefit life on Earth and to understand our place in the universe. This will begin with small robotic missions to understand the environment and prove new technologies to pave the way for the future. We will then move on to increasingly ambitious missions with humans and robots working together, learning to live and work at the surface and performing new and important scientific research. This new exploration will be achieved not in competition as in the past, but through peaceful, international cooperation. Eventually, we will see a sustained infrastructure for research and exploration, where humans will live and work for prolonged periods. Here, we will put into practice the lessons of years on the International Space Station to establish a facility akin to those that we see in Antarctica today. In the future, the Moon can become a place where the nations of the world can come together to understand our common origins, to build a common future, and to share a common journey beyond. A place where we can learn to move onwards into the solar system. And perhaps in the future, at a sun-bathed peak at the lunar South Pole, at the edge of a crater, we will learn to access and utilize resources from deep below in the dark. We see water, ice, molecules trapped in the cold, a source of hydrogen and oxygen, essential for sustaining human life and for rocket fuel to propel us further into the solar system and onto the next destination of our journey into the cosmos.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study by the Great Barrier Reef Marine Park Authority has found that the 2021-22 summer season saw a further increase in coral bleaching and the hottest sea temperatures on record. The study outlines how, despite La Nina conditions, which usually result in cooler weather, the Great Barrier Reef's waters warmed during early December, which would put it as the hottest December on record since the year 1900, exceeding historical summer maximums, which typically occur in the hottest summer months. The report says ocean temperatures continued to accumulate heat throughout the summer months, going right through until early April. And that's led to the fourth mass bleaching event of the Great Barrier Reef in 7 years. An unprecedented occurrence. A new study warns that eating more fish may be linked to a greater risk of malignant melanoma. The findings, reported in the journal Cancer Causes and Control, suggest that people who ate an amount of fish equivalent to about 1 can of tuna a day had a 22% higher risk of melanoma compared to those who consumed the equivalent of a can of tuna a month. Interestingly, they also found a link to melanoma risk in people who ate more non-fried fish, but not those who ate more fried fish. Now, this study does not show that eating fish in any way causes melanoma. That's usually caused by the sun. However, the researchers do suggest that contaminants such as mercury in fish could explain the link. A new study has provided scientists with yet another reason to start the day by drinking a cup of coffee. The findings in the journal Kidney International reports show that consuming at least 1 cup of coffee a day may reduce your risk of acute kidney injury by 15% compared to those who don't drink coffee. The findings are based on a 24-year study involving some 14,207 people with an average age of 54. Scientists found 1,694 cases of acute kidney injury were recorded by subjects during the survey period. Now, after adjusting for demographic characteristics, socioeconomic status, lifestyle influences, and dietary factors, there was a 15% lower risk of kidney disease among participants who consumed at least 1 cup of coffee daily. And even after adjusting for additional comorbidities such as high blood pressure, body mass index, diabetes, the use of antihypertensive medication, and kidney function, individuals who drank coffee still had an 11% lower risk compared to those who did not. The study also found that the largest reductions, a 22 to 23% lower risk, was in those people who drank 2 to 3 cups of coffee a day. Coffee has already been associated with the prevention of chronic and degenerative diseases, including type 2 diabetes, cardiovascular disease, and liver disease. The study's authors from Johns Hopkins University say you can now add a possible reduction in acute kidney injury risk to the growing list of health benefits attributed to coffee. Apple has used its annual developers conference to launch its iOS 16 update and show the world what to expect in coming months with new technology and more powerful processors. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
WWDC launched new operating systems for all their devices and new hardware, 2 new MacBooks, the MacBook Air with 13.6-inch screen and the M2 processor, and a MacBook Pro, but in the same chassis, but with a fan inside. The MacBook Air doesn't have a fan. But with the operating systems, lots of new advances, but it's the most advanced set of OSs from Apple yet, with multitasking on the iPad and resizable windows, with the ability to use your iPhone wirelessly with your MacBook to get, the incredible pictures that your iPhone camera can provide as your video instead of a webcam or something else. It was really top-notch stuff and bodes well for the future iPhone 14 and iPad Pros and iPad Airs with the M2 chip. Now, not only did Apple introduce new operating systems, these are the developer beta versions that will be refined over the next 3 months and then launched in 3 months' time when the new iPhone's launched. And you get iPad OS 16, iOS 16, Mac OS Ventura, Watch OS 9. There was also sort of a bit of a preview of CarPlay. But in iOS, for example, we've got the new lock screen. That's sort of the headline feature where you can customize the lock screen to have different fonts for the time and date, and you can also put different widgets of information directly onto the lock screen. And this is sort of a clue to the rumor that the iPhone 14 will have always-on display and will have these widgets in sort of low-power mode like they are on your always-on Apple Watch. And then when you lift the phone or you sort of interact with it, they come to life. But that, of course, is not the only feature. They've got a smarter Spotlight search feature. They've got the ability to, when you use iMessage to send messages, you can edit a message after you've sent it. So the example in the keynote was, "Hey babe," and then something about a message, and you changed it to "Hey Gabe," because it got auto-corrected to babe or something like that, and you could change it. And then the message was delivered, but it hadn't been read yet. It looked as though you could undo the send. You could delete it. So you've been able to delete messages in WhatsApp, for example, but you can't edit them. So that's an interesting thing. Obviously, there's improvements to also notifications on the lock screen, where they now come in at the bottom and don't sort of cloud the middle of the screen and sort of block out that nice photograph that you have there. You can sort of infinitely reposition around. And there's intelligent widgets for being able to show you the distance your Uber ride is from you in a sort of a straight line rather than on a map. And you can sort of judge how much time it's got left to get to you, and it'll have a display of the time they're estimated anyway. And then you could have live sports scores. And this is all sort of from the lock screen. And when you have music in this bottom section as well, then when you're listening to music, the album art pops up, which Apple says lets you celebrate the album art.
I like looking at the album art.
Well, people have loved it in the vinyl days. It was a true art form.
Yeah.
And of course, in the digital world, Michael Jackson tried to have these little booklets in the CD covers, and then his tapes. You could pull out and look at different poses of him dancing on his bad. I remember it because then that was sort of the extra stuff you used to get. And then in the digital world, there was digital add-ons and things. But you can set up a Focus, which allows you to have notifications and apps, used for work or home or other scenarios. You can now also segment your notifications to only be notifications for work email accounts, work apps, work social media networks, and work things. Then you can have home, and you can really start to more intelligently segment your life if you don't want it to blend into each other, and then filter out things in the moment. Photos, you can take photos and share them with other people that are with you or part of your group as you're sort of together on a holiday or taking photographs. You can turn sharing off, and it's very easy to sort of be able to get all the photos that everyone's taken in a certain area. Other cool features are the ability for the iPad to now have multitasking in a new way that is also available on the Mac OS. It's called Stage Manager. You can see resizable windows on your iPad, and you can have up to 4 different instances of paired apps on the left-hand side. These little small examples of what the open windows are, and you can click between them, and you can actually have multiple apps that you can multitask between in this new way that also works on the Mac OS. And if you plug an external monitor into your iPad, you can now also use that external monitor, a fully featured external monitor that shows iPad app, shows the Stage Manager, lets you run separate apps on that separate screen and easily move things between the screens, and the little cursor just goes between the two when you're using the trackpad or a mouse or with a keyboard on your iPad Air or iPad Pro with the M1 chip. It's limited to the M1 chip, which means a lot of the older iPads can't get it, but Apple says it requires the power of the M1 to do this. And by the same token, it's got the new MacBook Air with the M2 chip. So this is the first time this second generation of chip has come out. This is a competitor for the M1. They've got different versions of the M1 chip, more powerful than the last. So this new M2 is not powerful than the most powerful M1 chip, but they'll have more powerful versions of those chips called M2 coming, later this year and the next and beyond. Apple's launched its new iPad OS, enables more multitasking than before. It's launched its new MacBook Air with the M2 processor, 13.6-inch screen, 1080p camera in the front, so a camera upgrade as well. You can actually use the iPhone camera wirelessly. You can put a little Belkin magnetic mount on the back of your iPhone 12 or 13 and connect it to the back of your Mac display, and it'll wirelessly use the camera that's on the back of your iPhone to give you a much better quality picture in Zoom or FaceTime or Teams or WebEx.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.